Hello everybody, we are live. We're going to do some regex today using C#. So what we're going to do first is we're going to try out one of those online testers for regex. We're going to write some regex and then we're going to put it into a .NET C# application. So some of the examples that I'm going to have a look at today include looking at the month and year. Quite often you have to validate that against a credit card or a debit card. You might have a look at credit card numbers as well, HTML tags, how to address with extra whitespace, what we can use with regex, IP address, validates. These are some of the examples that we can use. So I'm going to go ahead and share my screen and we're going to get going. So here we are. So the first thing we're going to do is we're going to try and validate the month and the year. As I said, you often see that in a credit or debit card. So we're going to write some expressions first. So this is what we're sort of trying to validate. So I suppose the easiest way of doing this is just to look for any number, the first two numbers, any number, so between 0 and 9 for the first two characters, and then followed by a /, and then we could do that for the next four numbers to represent the year. And I think we need to escape it. Yeah, we need to escape the / with a \. So / in regex is something that's reserved. It's reserved at the beginning there. So we can see there that that sort of validates our regular expression. But the issue we've got there is that we can just put in any month. So we could put in 34, which doesn't exist as a month. And we could also put in any year as well. So I think with that, we could probably tighten it up a little bit. We can make that a little bit better. So what we're going to do is we can say that for the first number will be 0. We want it to follow with either 1 to 9. So what we can do with that is we can do that, or so we do 0. So that will represent 0, 1, 0, 2, 0, 3, 0, 4, or we can have it begin with a 1. So this little pipe here is the OR sign. Sure you're familiar with that if you're familiar C# programmer. And then we can say for the second number, it's 0 to 2. So that will represent 10, 11, and 12. So that should now validate the month at least. So if we put 0, 0 in, it doesn't work. If we put 0, 1 in, as you can see, we're getting a match there. 0, 9, we put 12 in, put 10. Okay, so that's good. We've managed to validate the month there. We're going to put in our / after that. Now to do the year, if we're doing a credit card expiry date, for example, it's going to be a date in the future. We've pretty much finished 2022 now, so you'd expect all credit cards to pretty much be in 2023 or beyond that. I'd say we'd probably set it a limit to say 2040. So what we can do is for the first part of the year, we're going to expect 20. So that's pretty straightforward. Then for 2023 onwards up to 2030, what we're going to do is so we'll expect it between 3 and 9. So that'll be 2023, 2024, 2025. So we can go ahead and test that. So 2022 doesn't work, but 2023 it is giving us a match, and up to 2029. Beyond that, it's not working. So if we wanted to do it for the 2030s, we could once again put an ampersand sign in there, and we can put the 0 to 9. So we're expecting a number after the 3 between 0 and 9. Now just to tighten this up, we can put that up there where it represents the start, the meta escape. And then we got the $sign there that represents the end as well. So if we started putting characters beyond it, then it's not going to validate. So yeah, we can see there, date in the past, 2010, that's not validating. So we're going to move that now into our console application. We're just going to make a note of that there. We're going to do a bit more regex first before we actually start using it in C#. So we're going to go ahead and do that. So credit card number, I think that's sort of typically between 12 to 16 characters. I don't know off the top of my head. So with that, you could probably just do that as a relatively simple regex. So if we were to put, yeah. So what that is it's saying any digits between 12 and 16 characters. It's relatively straightforward. It doesn't allow for spaces in that. So another way we could do that is if we're expecting 4 numbers followed by a space, we could do that. So the \d is the digits, the \s is a space. So we could just keep on doing that. And we will do that up until, if we're expecting a 16-digit card number, we could do, yeah, so if we go ahead and do that, there we go. So this will expect 16 digits, but with spaces as well. So if we took out one of the spaces, as you can see, it's no longer validating, but if we put that back in, and what we can do as well is if we sometimes expect 12 digits, we can set the last rule as an optional. So what we can do is we can wrap it around in brackets, and then we can put a question mark next to it. So it's optional. It can be there or it doesn't need to be there. So you can see it's still matching the first 12 numbers, but it's not going to match the last part unless we add a space and the last 4 characters. So we're going to go with that as our credit card validation. So at the moment we've got expiry date, credit card number. HTML tags is the next one I've got on here. This one's a bit more tricky. So what we can do is we can say any, so it starts off with, don't know what they call that. Is it a chevron? I'm not sure what they call that tag, but anyways, it's that tag there that we need to use. Normally you've got any sort of lowercase letter before it closes off the bracket. And then normally you'd go ahead and you'd have anything that's not the initial opening bracket for the HTML tag. And then you can close it off. So it will be the opening bracket for the tag. It'd be a /, which we need to escape with the \. And then once again, any letter that we have would go in there, and then it would finish off with a closing tag. We're going to put the start and beginning. Let's just see if that's actually going to work. No, that doesn't seem to work for some reason. There's probably there we go. We need to ensure, so the plus is 1 or more characters. In fact, that probably needs to be a star, which means it could be 0. So if we have that as an empty tag, that would still be valid. Now this won't quite work because if we've got attributes in the tag, then it's not going to validate. So we could just, we know that it's not going to, we're looking for this tag here. So we know that's not going to be included in the attributes. So we can go ahead and put this bracket, this symbol here, the character class, where it's not the closing tag, and that can be anything in between it. So if we wrap it around in brackets, so you can see there now we're getting a match when we start putting attributes in. So that's going to match the regex like that. So that's for HTML. I'm going to add that there. We've also got extra white space as well. So what we can do with this as well, so we can mark, so if we find a space, but then we might have additional spaces after that. So it'll be 1 or more, so we'd need the plus around it. So we'd probably do something like that, I reckon. Maybe that. Let's have a look. Yeah, there you go, you see. So we've got the initial space there, and then we've got the additional white space there as well. Now the good thing about this is that if we're running this in a C# application or .NET application, we can go ahead and replace that extra white space. So we can effectively take this out so it's only got one white space, just in case someone's filling out a form, they're pressing space too many times. That's what we can do with that. So we're going to add that in as well. IP address is a good one. So we know with IP addresses, they don't go beyond 255. So what we can do with that, so this one's a little bit more tricky because typically you wouldn't put the preceding zeros before the IP address. So yeah, not sure how we're going to do this one, but let's give it a go anyways and see if we can do this one. Or should we do, yeah, no, we'll give this one a go. So it can either be, so I think we know we've got 200 to 255, so I think that'd be a good one to test first. So it will start with 2, and then it will be 0 to 5. Now this is not going to quite validate because it's going to go beyond 259. So, but what we can do is, we'll come back to that, but yeah, at the moment, that's going to bring anything from 200 to 259. So validates 200, 255, but also 259 as well. Because what we're doing here is we're expecting the first character to be 2, then any character to be between 0 and 5, and any character between 0 and 9 after that. What we could do though is if we change that to a 4, and then we could just put a bracket around that and have another OR statement with these, with the second and the third number. So we could do this. So we've got, it's either 0 to 4 or 0 to 9 for the second and third character, or it's 5 and the third character will be 0 to 5, like that. And a closing bracket. So let's see if that works. Yes, that works, you can see. So it's validating all the numbers from 200 to 255 on that one. So we managed to do that. So we've got this opening bracket here. We can do an OR there. So now we validated the 200 hundreds. Now we're going to validate the 100s. That one's a lot more simple. Literally, it's 0 to 9 or 0 to 9. So that now is going to validate 100 to 199, and then obviously from 200 should still be validating that as well. We can see that's validating. So that's good. And then after that, between 10 and 99, we're only going to expect 2 numbers as well. So we can put another OR around that. So we can just simply do 0 to 9. In fact, there is a nicer way of doing this, I've just noticed. So we've done 0 to 9 there twice, but rather than doing the second one, we can just put 2. So now it's expecting 2 there. In fact, with this one, what we might be able to do is to do either 1 or 2. So that would match 5, 9, 16, 88, 96, 105, 199. But yeah, this is always the problem though. It's still validating. It's validating all numbers by the looks of it. So yes. So we're expecting, so it can either be, I think that might work. I think the problem is at the moment is that we haven't filled out the full, like we haven't put an end in there. If we put a beginning and an end, I think this might actually validate. Yes, this is validating now, you see. So it's validating every number. And then, yeah, so that's now validating every number for the top part. Then after that, it's just a simple case of we can just keep on repeating this. So that's going to validate the second part of the IP address, like so. So if we were to put 267 in or 256, it's not going to validate. And we can just keep on repeating that for the other numbers. So that's 3 and 4. So now we should be able to get a full IP address and validate it with regex, which we can do. We've got all our numbers in there now that's validating. So that looks like it's working. So we're going to go ahead and add that in. And we've got validate. Last one I'm going to have a look at is valid URLs. So how we validate a URL. And then after that, we're going to go ahead and test it in a .NET application, a console application with C#. So, right. So with the URL, we're going to type in a URL in here. So we know it's going to begin with HTTP. All URLs should start with HTTPS now. They all should be secure. If you don't have that, you get a little warning on Google Chrome saying it's not a secure website. And then we know it's going to begin with that. And then this is normally a series of letters, dots, hyphens, potentially. I don't know if there's, oh yeah, there are. We can see up there, there's sometimes numbers in there as well. But that's okay. So we can start, we do the beginning, we do the HTTP, then the S is optional, so we wrap it around with brackets, and then we put a question mark there, saying that it can appear there 0 or 1 times or as many times as possible, given backing as needed. And then we know it's 2 forward slashes, so we need to escape them with the backslash. And then here, this is going to be a series of letters, numbers, hyphen, which we need to escape with a backslash because it's one of the reserved words in regular expressions. And then we can also have a dot there. And then, yeah, from there, that sort of gives us this part of the URL. So we stop that. Let's just see. So we need to ensure that it's got 0 or more. So it's got 1 or more in there. Right, why is that not working? So we've got the HTTP and then we've got the optional S in there. And then we can have A to Z, 0 to 9, backslashes or a dot in there. So why is that not working? Why are we not getting any results from that? Let's have a look. Let's start that again. So HTTPS, so we've got that part there, that's fine. I'm wondering if we forgot the colon. I think we've probably forgot the colon, because there's a colon before the forward slashes there. So yeah, once again, this can be 0 to 9, A to Z, dots or a hyphen. There we go. Yeah, so I think we were forgetting the colon, hence why it wasn't validating that time. But we can see that's validating now. But what we can see now is that anything beyond the protocol and the host is not validating properly. So what we can do with that is we know it's going to be a forward slash. So we just do that, and then, I mean, this is a cheating way a little bit. I mean, we're being a bit lazy there. We could validate that it's probably going to have letters, numbers, hyphens. We know it's going to include some forward slashes as well. And then, yeah, there we go. That's not going to include the query string. So if we want to include an optional query string, we have to add it there. So we put it around in a capturing group, in a bracket, and then question mark is a reserved word for 0 or more times in regex. So we have to put a backslash next to it. And then this part here expects any characters beyond that. And the question mark here after the group states that it's optional. So we don't have to include it if we don't want to, but we can see if we do include it, it's part of the extra group, which is what these brackets represent. So each of these brackets represents a particular group in the regex that we can use. So let's put that in there and let's just start using this in C# now. So what we can do is we want to extract the month and the year from a debit. So we want to validate a debit card. So we want to extract the month and the year. So we're going to do that first. So we're going to create a variable of expiry date. And we expect it to expire in a year's time. So 12/23. So that's December 2023. We want to store that and that into separate variables. So the way we can do that is if we go in, we'll declare an expiry month. Now we're already importing the system.text.regular expressions. So we've got this regex class here that we can use. So there's a few ways you can do this. You can use first of all, you probably want to do a bit of a match on it to make sure that it actually matches, that this string actually matches. So you can do regex.isMatch. So the input is the expiry date and the pattern is the pattern that we've got up here. So I'm going to put that in a constant actually. So expiry date regex. And then we're going to put that in there because we're going to use it a few times. Why is that complaining? Oh, I need to set it as a string, that's why. There we go. So if it's a match, we go ahead and we get our month. So we do regex.replace. We get the expiry date, the pattern, and then what we can do is I'm just going to see if we split this up into groups. Yes, so you can see with these brackets here, each bracket, an opening bracket represents a new group and then it's closed off with the closed bracket. So this part here, this is the first group. So this would represent $1 in regular expressions. Now with this one, we've got a group here, which would be $2, but if we wanted to get the year, we'd need to add a new group in there. So we can do that by adding that into the expression like that. So now this will consist of 3 groups. We've got a group there, we've got a group there, and we've also got a group there. So you can have a group within a group with regular expressions. So we're just going to update that. So we've gone ahead and done that. And now we're going to get the month out. So what I said is we've got the first group there. So that represents $1. So we can simply put $1 in there. Like that. Hey Raffle, I hope you're enjoying the stream. So we've done that. And then we can say if it's not valid, then we just return an empty string. And then we're just going to output that. And to make sure that it works, can we name each group and use the name as a key? I don't think we can. I'm not aware that you can. I think it's just literally this group here is the first one. So it's represented as group 1. That is the second group. So it's represented as group 2. And then this one here is the third one, so it's represented as group 3. But I will look into that because I'm intrigued to see if you can do it. So you can see there, we've managed to get the month out of there. So if we get this into one line so you can actually see the code properly. So we've done an if statement with the regular expression to make sure that this expiry day here is a match. We go through and we get group 1 and we set it to the expiry month. We can now go ahead and do the same thing for the year. So we can replace the $1 with $2 because it represents group 2. It's this part here. And then we're going to output that as well. There we go, you can see. So we've got the first part there, which is 12, and the second part, which is 2023. So we've managed to set the expiry date month as one variable and the expiry date year as the other variable. So another way you can do this as well. So obviously with this, you can't do a lot with the variable that we're replacing. So literally you got $1, but what you can do is you can use, there's a couple of overloads for regex replace. So this is the one that we've been using, the string replacement, where you simply just represent the group number with $1. But you can also use this first one here, which is effectively a delegate. So we can do this. So what we can do is, so the value, we can simply just return the E value, and that will represent what we're getting, what we're replacing. So we're replacing, excuse me. So we're replacing the whole lot. So if we run that, let's just see what that's actually returning. Yeah, so at the moment that is the full value. But what you can do is, so if we wanted to get the first group, we can call the e.groups. So E is a type of match, and you can do groups. So 0 is the whole lot, and then 1 is each individual group as well. So if we do e.groups1, and I think you have to pass back value in there. So you can see now if we put that into our watch, you can see there it's returning 12. So I'm hoping you can see that properly. But yeah, it's representing 12. If we wanted the second group, it would come back with 2023. We've also got the third group, which gets the last 2 digits of the year. So putting 3 in there represents the 2023 part of it. And yeah, we can keep on doing that. So 0 will represent the whole value, the whole regex. You can just simply call e.value with that though, and it represents the whole lot. So with that, that's quite good, because if we wanted to, I don't know, do some sort of calculation with that, we could do it through this method rather than the simple string replace, which you can't do an awful lot with. So we've done that with that. We're going to keep that like that. Let's see what else we can do. So yeah, one thing I do like to do quite a lot is I like to remove a lot of this white space. Quite often when someone's filling out a form, they will put too much white space in, and it does end up being a little bit excessive with the number of bytes that you're storing, particularly if there's only intended to be one space as well. So what we can do with that is, so if we put it into a regex, so this is just excessive white space. I would say that probably needs, no, that's fine. Excessive white space regex. So you can see here we've got way too many spaces. We've got about 6 or 7 spaces in there, and we don't really want to be storing that in a database. So we can use a little bit of regular expression to get rid of that. So we do a little replace here. So regex.replace. Again, you can do the is match as well if you want to. We're not going to do that at the moment, but you can do that if you need to. So the pattern here is what we've stored up here. So it's a space followed by any other spaces, and then simply we can remove that. So with that, we want the first space to be there, but we don't want any more spaces after that. So what I'd probably do with that is I'll probably put that in a bracket and then put that in a separate bracket as well, so we can just replace it with that. There might be a better, in fact, I actually think there's a better way of doing this. I think what you can do is you can get rid of that and you can have 2 or more. So this represents a minimum number of 2 spaces or more. If you don't put a number there, like you can put 2 to 9 spaces, but if you don't put a number there, then it'll assume it's infinite up until the fact that we don't get any more spaces in there. So I think that will probably work. So that should hopefully, but will that, the only problem with that is it might just completely take out all the spaces. So I think we probably need that first space in there. I think we need that. I think that is what we actually need. I was trying to simplify it, but I think we need that first space in there first, so then we can replace it with that. Let's have a look anyways. Let's give it a go. So if we write it out to the console, and let's see what happens. So we've got a breakpoint on there. Right, let's see what it's doing. Yeah, there we go. You see, so it's got rid of all our excessive spaces. So it's literally got the 1 space there, which is what we want. We don't want to be storing data where someone's put, you know, playing around with the spacebar and being completely annoying, because that's just not going to be good enough, I'm afraid. So we've done that. What other bits can we do? Ah, yes, we're going to try it out with HTML tags. Now, I said earlier, HTML tags are a little bit more tricky because in this example, we sort of want to match it with a particular tag name. It can be a bit more difficult because you need to try and match the end of the tag name. And with regular expressions, you can do double not statements, but they can get very resource intensive, and I have had issues with applications before when doing that. So what we're going to do is we're going to create a HTML tag regex. And we're going to put our one that we created from earlier in there. And then we're just going to write some HTML. So we'll put a link in. Put my website in there, because why not? Right, what we're gonna try and do is we only want it to validate if it begins with an A tag. Or no, we only want it to validate if it's an A tag. So we only want to store our link, our actual tag, if it's in there. So what we can do with that is we can do an if. So we'll create another variable. It's valid A tag. Set it by default to false. Now, what I will say with this is that I've always found that using like string, I think it's string.match, is always going to be a bit less intensive in terms of resources. So if you can get away without using HTML, without using regular expressions, then I'd certainly recommend that. But, you know, regular expressions has a lot more functionality. So, you know, I think definitely if you need to use regular expressions, and I'll most certainly do it. So what we can do with this is we can say regex.isMatch, and then we can put in the, what are we going to do? Well, no, what we can do actually, we're not, yes, are we? Yes, we are going to do that. so we don't need to do that. We're going to say we're not going to have an if statement. All we're going to do is, what do we want to do here? Because we sort of want to, yeah, we just want to know what that part is. Or do we want to, or we could, what we could do is we could put an extra attribute in there, maybe. That might be an option. Let's go ahead and let's have a look. So my HTML tag equals regex.replace. We'll put in the regular expression. In fact, we need to put in the input first. So my HTML tag, put in the regular expression, and then we're going to use the delegate to do this. So only, yes, so we've got the groups up here. So the first group represents the tag name. So we can say if e.groups1.value equals A, what we're going to do is we're just going to append to the tag. So we return the usual value for it, but we're also just going to put this is a valid link, just to check that it actually works. So I would expect now that it's going to append this line. This is a valid link to the HTML tag. Let's see how it gets along with that. Are we getting an error here? I think we are. Oh yeah, of course we are. We just need to return. We need to return a value after the if statement like that. Okay, let's give that a run and see what happens. We're just going to remove that. Give that a run in our console application. So yeah, you can see there, because it starts with an A tag, we've added that this is a valid link. Let's just change this now to a div tag. We don't need that in there. So it shouldn't add this extra text there, because the first group is not going to equal A. It should equal div if we've got the regular expression right. And you can see there, it hasn't added the extra text in there. So we know that's working, and that's quite good as well. So we can do sort of it's a different way of doing a match. So if we wanted to change particular stuff based on a particular condition or add particular text, then we can go ahead and do that. It's just a little bit of extra functionality that you can't do with a simple string replace. Okay, so what else have we got? We've got IP address there. We've done, yep, I mean, that's pretty straightforward anyways. An IP address, if you wanted to get like the first part out, I mean, you just look at each of the individual groups and extract each number there. Same with, oh, this is a good one. So this is going to be our final one. We're going to have a look at this, is how we extract the host name out of a particular full domain URL. So we're going to put a HTTP, well, put a URL regex there. We're going to use our regex for our URL in there. So that's all good. I'm going to remove that for now. Yeah, so this is our URL. And we want to get the host name out of it. So what we can say there is, well, we can do a match on it. So if regex.isMatch, the input is the URL and the pattern is the URL underscore regex, which is our regex for it. So if it's a match, we're going to declare a new variable. We're going to call it host, and we're going to set regex.replace, and then once again we're going to get the URL and the URL regex in there, and now we're going to find out which group it's going to be. So we've got the first groups there, which is the optional S, so it looks like it's going to be the second group. So we can simply go ahead and put $2 in there, or we can do it the other way as well. So we can use the delegate, bring that in, and we can return the second group, so e.groups, and then the value for that. So there's two ways of doing that. I'm going to output that to the console like so. And then hopefully, if we run our regular expressions now, yeah, we can see we've now got the host name out of that. So we know that that's successfully working. Okay. So thanks very much for watching. There's a lot of stuff you can do with RegEx. It's a very powerful tool. Bear in mind though that it can be quite resource intensive, particularly if you're using double negatives as well. But you know, for sort of the more complex replacing of data or strings, then it's very beneficial. Thanks very much for your live chats, and I'll talk to you soon. Thanks very much for watching, and goodbye.